Yes, we did not finish that, but let me, no, that's okay. Let me start with your question. Yes.
Oh, I just need,
Yes.
I have a question, I'm just stuck on how to I didn't process it.
Okay, so let's talk again about the whole thing. And I will show an example from each, or at least one problem from each type of problem, and then we'll go back to your question. How is that? Okay, anything else, other things, anything prior to 8.1 that we would like to look at? Okay, so let's take a look at again at sequences. A sequence can be given to us in two different ways. If we are given the general term, so a sequence can be given to us by the general term, which is a sub n, a lowercase n, or it can be given to us using a recursive formula. What is a recursive formula? The recursive formula is something like, I cannot determine term 10 if I don't find the previous term. I cannot determine term number 9 if I don't find the previous one. So that's a recursive formula. Okay. So one more time, what is a sequence? A1, A2, dot, 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 AN, dot, dot, dot. So this is an infinite sequence. It's basically a function that connects the real numbers or natural numbers to different terms. That is, for us, for what we're trying to do, less important. But this is a sequence. It has the first term, the second term, the third term, the general or generic term, general term, and so on and so forth. Infinite sequence of numbers. So let's see what happens when we are given a general term. Then let's see what happens when we are given a recursive formula. In both cases, we will be only asked just one thing, to determine the first 4 or the first 5 terms of the sequence. So let's start with this situation. On page 752, let's say we're looking at problem 7, 752. We're given an, which is the general term, which is -1 raised to the nth power, and everything multiplied by n plus 3. All these are n. An, -1 raised to power n, in parentheses n plus 3. And as I promised, we're asked to find the first 4 terms of the sequence, meaning I have to find A1, have to find A2, A3, and A4. When I am asked to find A1, what do you think I will do? I will replace n by, that's it. So this will be -1 to the first power multiplied by 4. But -1 raised to the first power is -1 times 4 will be -4. That's all I need to do. When I'm asked to find A2, exactly, -2 raised to the second power multiplied by 2 plus 3, which is 5. -2 raised to the second power is 4 multiplied by 5. That's it. A3, -1 to the third multiplied by 6. Oh, because I wrote 2. I'm so sorry. I didn't mean to write 2. Thank you. So this is -1 squared, which is 1 multiplied by 5, which is 5. Sorry about that. Sorry. Sorry. So -1 to the third is -1. -1 times 6 is -6. And the last one, -1 to the fourth multiplied by 4 plus 3, which is 7. -1 to the fourth is 1 times 7 is 7. So this was an example in which we were given the general term. We were asked to find 4 terms, the first 4 terms of the sequence. Okay, now let's look at the other type. We are given a recursive formula. Let's pick, you can pick if you have your book. It's up to you. Let's say 17. Same page, 752. A1, we are given it's 4. And AN, which is the general term, is given to us indirectly 2 multiplied by n minus first plus 3. This formula is valid for n greater than or equal to 2. We're asked to find the same thing. Let's read. Are defined using, okay, so these sequences are defined using a recursive formulas. Write the first 4 terms of each sequence. Yes, Joseph? Say it again.
The first one going to be 11, or no, A2 is going to be 11.
A1 is still the first.
Yeah, A1's 4 minutes.
It is given. Yep. So this is A1 equals 4. Now A2 means I have to replace n by 2 everywhere. So how much is 2 minus 1? 2 minus 1 is 1. So this becomes A1, and I have A1. So this is 2 multiplied by 4 plus 3. This is the so-called recursive formula. The order of operations, 2 times 4 is 8, plus 3 is 11. And we determine the second term of the sequence. Can anyone give us the third term? How do I write the third term? Yes?
A3 minus 1, which is A2, which is 11.
Very good. And plus 3. 22 plus 3, 25. That's it. And the fourth term of the sequence. 2 times 25 is 50. 50 plus 3 is 50. So that's the only difference when we are given a formula or when we are given the general term. Do you think we need to practice? We're going to have a few examples in the review. But right now, do you understand what the difference is? Do you need to practice more of this? Okay. So let's move on. Now, if you remember, we started last time. I'm sorry. If you remember, we started last time, but I didn't mention more than just this. So I'm going to have to discuss about factorial notation. So 4 factorial is 4 times 3 times 2 times 1. By convention, I'm going to write this again. 1 factorial and 0 factorial are both 1. Kind of unusual. We've never had something like this before, right? 2 different things to be the same expression or number. So let's take a look at simplifying, like, let's say 26. In 26, we have 20 factorial divided by 2 factorial times 18 factorial. I will also show you how to use this, how to put this in the graphing calculator.
Was this the same page number?
Yes, they're all the same. This is the last page for the class. That's it. Bless you. 752. That's it. Okay, so remember, by definition, n factorial is n multiplied by n minus 1 multiplied by n minus 2 dot 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 times 3 times 2 times 1. That's the general form for n factorial. So for example, if I have 10 factorial, I will have 10 multiplied by 9 by 8 by 7 dot 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 times 3 times 2 times 1. I can also express this as 10 times 9 times 8 factorial. 8 factorial meaning 8 times 7 times 6 times 5 times 3 times 4 times 3 times 2 times 1. So coming back here, yes, I can put this in the graphing calculator, but you have to be careful because in certain situations it will exceed the capacity of the calculator. So which of these two, I know it's silly, which of these two numbers is bigger, 20 or 18? Well, I know you're going to say 20. So I'm going to use this concept and write 20 times 19 times 18 factorial. Can anyone say, why did I stop at 18 factorial? Because there is an 18 factorial in the denominator. So 2 factorial is 2 times 1. And then I can simplify this, and the whole thing becomes very simple. And then 2 simplified with 20. So I get 190. So that's why I was asking from, yes, Joseph, go ahead.
I'm sorry, wait, so like 3 factorial would be
3 times 2 times 1.
right, okay.
Yes. And 0 factorial and 1 factorial are both 1. Okay, so now, is that clear why I stopped at 18? I didn't want to proceed, and I could have continued with 18 times 17, but why? Since I saw that these two are the same and I can simplify them, I stopped at 18 factorial, and of course I started with the larger of the two.
So it just means everything after it doesn't even matter? Like 17, 16.
But I have 18 factorial simplified by 18 factorial. Since they are the same, I get 1 and 1. Yes, Stephen?
Now.
Is that clear?
I mean, if it was 212, you would keep going until you got to 12?
Yes.
Okay.
Yes. So if I have 20 here and 12 here, I would have written 20, 19, 18, 17, 16, 17,
Right,
16.
but what I'm saying is, so 17, 16, 15, 14,
I would have to
after
multiply.
18 matters anymore.
Because
there's one on the numerator.
right,
on the
it's the same thing with 2 times 10 over 10. As long as these two are the same, I divide by 10 and I get 1. I divide by 10 and I get 1. 18 factorial divided by 18 factorial is 1. 18 factorial divided by 18 factorial is 1. So we simplify the expression. Sorry.
So did the factorial next to the 2 you transferred it over? Did I cancel out with the 20 with the factorial next to the
Yes,
2?
because this is 20 without factorial. I cannot cancel something with factorial with something that has no factorial.
So then where'd the factorial go with the 2 then? 'Cause,
It's 2 times 1.
okay.
2 factorial is 2 times 1.
Gotcha.
Yeah. If it were 3 factorial, I would have written 6. Or I would have written 3 times 2.
Okay.
Better?
Yeah.
Everyone? Better? Okay. So let's look at another example. Let's say 25. I feel that this is useful if we look at another. 14. So which of 16 and 14 is larger? Of course, you're going to say 16. Since the denominator is 14 factorial, what will you write at the top? And of course, 2 factorial is still 2, and this is 14 factorial. You will
16 times 15 times 14 times 15.
exactly. Since these two are the same, I will simplify. 2 and 16 will give us an 8. All I have to multiply is 8 times 15. So now let's look at which of these two you would like to look at with the graphing calculator. And I think I yes, I did start it. So which one?
First one.
The first one. So you want the 20?
Yes.
Okay. Factorial symbol is in math. Go all the way to probability. And this is number 4. And you divide in parentheses by 2. If you want to put factorial, but 2 factorial and 2 is the same thing, but let's go ahead and put factorial. That's number 4. And multiply by, and we had 18. And I have to copy the symbol of factorial symbol. Go to probability and then 4. Close the parenthesis and press enter. And we know that the answer is 190. Is this okay?
It is.
So be careful, we still need to know how to simplify. And number 2, the next example, we'll not be able to use the calculator on. So let's take a look at the next one. Ready? Ready? Okay. For example, of course, I'm sorry. Let's say 27. Same page. N plus 2 factorial divided by n factorial. We can't put this in the graphing calculator. But we know exactly which one is larger. Which one is larger? N plus 2. So how would you, keeping in mind that the denominator is n factorial, what would you write for the top?
N plus 1.
That's it. These two will go away, and the simplified form is n plus 2 times n plus 1. Do we understand this?
Mm-hmm.
And I will expand, and I get n squared plus 3n plus 2. Which I could have not done with the graphing calculator, with this one anyway. Let's look at another example. Any questions? Let's also look at 28. And that is 2n plus 1 factorial over 2n in parentheses factorial. Which of these two is larger? Perfect. So leave the denominator alone and tell me how to write the numerator. That's it. Because 2n plus 1 minus 1 would be 2n. So the answer is just 2n plus 1. Any questions?
Yeah, well, this would be a factorial in the parentheses, but whenever there's like a 2n plus 1 or 2n, like,
If I have two, if you're talking about this,
yeah.
only n is factorial, not 2n. So this is simply 2 multiplied by n factorial. Very good. Let's look at problem 33. A different type of problem now. Find the indicated sum. And here it is. The sum from k equals 1 to 5 from k multiplied by k plus 4. All we have to do is create the terms and add them, because this is what the symbol is telling us to do. This is the summation notation, sum. Okay, how many terms do we have? When k is 1, exactly. When k is 2, when k is 3, when k is 4, and when k is 5. So I have to find 5 terms and add them up. First term, can anyone dictate the first term? So when k is 1, 1 times 1, you're correct. I just want everyone to see. When k is 2, 2 multiplied by, very good, plus. You're right, but I just want everyone to see how we
Wait.
get.
No, I don't understand.
When k is 1, 1, 1, 1, 5, plus. When k is 2, 2, 2 plus 4 is 6, plus 3. When k is 3, 3 multiplied by 7. When k is 4, plus 4 multiplied by 8, plus when k is 5, and that's the last one, 5 multiplied by 9.
Okay.
So now, yes, we will perform the multiplications by the order of operations, correct? Well done. So then we have 5 plus 12 plus 21 plus 32 plus 45. Okay, so let's add them up. Okay, thank you. If anyone else got 115, I don't have to do anything. Thank you. Okay, let's look at another. Yes?
Last, this one for example, for this one. What you said 2n plus 1, I'm confused about the 2n.
Which part? Where? This 2n?
The one on the top, the one on the numerator, yeah.
You have 2n plus 1, and I remove 1. You give me 1. What are you left with? That's it. What will be the next term? The next factor, I should say. 2n minus 1. What will be the next one? 2n minus 2. What will be the next one? That's it. You can't touch 2n. Very good question. Okay, so here's another. 41. We're asked to do the same thing. From I equals 1, they're using I now. I, J, K, they all mean the same thing. I factorial divided by I minus 1 factorial. They want us to add how many terms again? 5 terms. Let's write the first, the second, and then decide how to add them.
Can we do this like real slow?
Yes.
Okay. Like, I mean, like, break it all the way down.
Yeah, it's 1. 1 and 1 and 1.
No. When you write this out, I want you to take your time.
I have to plug in 1.
That's fair.
So it's 1
Same.
factorial. 1 minus 1 is 0. 0 factorial. And I'm done with I equals 1. I plug in 2.
Okay. Yep, I got
2
it.
factorial over 1 factorial.
Then it would be 3 factorial over 2 factorial.
Very good. Plus.
Let's see.
4 factorial over 2 factorial.
Plus. Last one.
5 factorial.
That's it. So now, of course, I'm going to simplify. So remember, 1 factorial and 0 factorial are the only ones that are given us as one and the same thing. What is it? Exactly. So then the first one must be 1. The top is 2 times 1, and the bottom is 1. How much is 2 over 1?
2.
Perfect. Plus. Now here's how I will simplify this. Of course you can calculate. They're big, very small numbers, right? 3 times 2 factorial over 2 factorial.
3.
That's it. What will the next one be?
4.
That's it. And the last one. Here's how I calculate. 5 with 5 is 10. 15.
He's so small. This is ridiculous.
Ridiculously easy. I got it. Okay, one word. Yes, Stephen, go ahead. You wanted to say something? Joseph? I'm sorry.
So for like 4 factorial over 3 factorial, it would just be like, you would just change it to 4 factorial times 3 factorial.
And I simplify the 3 factorial. Exactly. Yes.
Can you go over the last step on how you did your
Yeah.
addition? Yeah, that final part right there.
This is 10.
But how did you get 1, 2, 3, 4, 5?
1 factorial over 0 factorial is 1.
Uh-huh.
2 factorial over 1 factorial is 2.
Uh-huh.
3 factorial over 2 factorial is 3.
Because the factorial.
4 factorial over 3 factorial is 4. And this is 5.
3 factorial.
3 factorial over 2 factorial. 3 factorial times 2 factorial over 2 factorial, and I simplify and I get 3. Then 4 factorial would be 4 factorial times over 3 factorial. This will be 4 times 3 factorial over 3 factorial, and you get the 4.
Okay.
And the same thing with the 5. Is that good enough?
That would do.
Should I show the 5, or is it clear? Okay. Last type of problems, and we can look at review. Okay, so let's say problem 45. Same page. This is the last page. 2 plus 2 squared plus 2 cubed plus dot 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 plus 2 to the 11th. All they want us to do is find a simple notation, which you may say is not simple, but to express all the sum using the summation notation. Yes, Joseph, go ahead.
Wouldn't it be like I equals 1 at the bottom and then 11 on the top?
Very good. The lower limit is 1, the upper limit is 11.
And then 2i for the
2 raised to I. That's it. Yes, perfect. When I is 1, I get the first term. Plus, when I is 2, I get the second term. Plus, when I is 3, I get the third term. And I continue till I get to the last one. Plus 2 to the 11th. That's it. Okay, let's look at one more. Let's say problem 50. But I hope you agree that this is not as difficult as chapter 5 was or chapter 6 with the Gauss-Jordan. You just have to pay attention. Okay.
That's a little more of that.
Yes.
Yeah.
Of this one.
Yeah.
Yes, that's exactly what I'm. Yes. 4. 4 squared over 2. 4 cubed over 3 plus dot 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 plus 4 to the nth over n. They want us to write it condensed. It's a sum of terms And we want to write it using the summation notation. And that will be the end of the material for this semester. Done. No more new. Remember, it doesn't matter what you use. You can use I, K, J. It doesn't matter. Let's use K.
K equals 1,
Correct.
and then above it's going to be 1 n. It's going to be 1 n over n. Or 4 n over n.
So when K is 1, I get this term, which is 4 to the first power over 1. When K is 2, I get 4 to the second power over 2. When K is 3, I get 4 to the third power over 3.
So is it 4 and
But I have to use K.
4K
4 raised to K
raised to K
over,
over K?
awesome, and the last upper limit,
And
exactly.
Hmm,
Very good.
fancy.
Okay, one more. Okay, so let's look at 52. 1 over 9 plus 2 over 9 squared plus dot, 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 n over 9 to the nth power. So this is, one more time, this is the Greek letter S. Why is this better? Why do we use this? Because this is not convenient for such a notation. But the Greek letter sum, S, or sigma, the Greek letter S, called sigma, is more convenient for what we're trying to do. This is good, but not as good or as comfortable as this one is. So, let's say J. I want to,
9 or 8? 1 over
9.
over 9.
J equals 1.
till upper limit n from
1 over 8.
J
Over
1
0
raised
over
to
9.
say it again,
0 over 9.
J over 9 raised to J.
9 raised to j, correct. When j is 1, I have the first term. When j is 2, I have the second term. When j is 3, I will have the third. When j, I finally get to the last one, I get this. Very good. Good. So this is, as I said, the end of the material for this class. No more new material. So now let's start the review. Ready? Okay. So since this will take just 5 minutes to complete, let's start it at the end and finish this page in a blink. Let's do just that first, and then you choose. Say it again. So, no, because we do not have class on Wednesday, and because I'm not going to be able to finish in 45 minutes the whole thing, I think we should have the test the following Wednesday,
So not Monday?
not Monday. But now
Bless
if you want Monday, it's going to be Monday. I don't have any problem, but normally I just want to share something from my own experience. You may not be like me, and I hope you're not. If I'm not ready for Monday, I will not be ready for Wednesday. Because I will say, I have 2 more days. So please don't be like me and be ready for Monday and then take the test on Wednesday.
Okay.
Is that a good point?
Yes.
Okay. So please do not rely, the point I'm making is, do not rely on Monday and Tuesday to get ready for Wednesday test. That's all the point I'm making. Does it make sense? Okay, very good. So let's start with this. Write the first 4 terms of the sequence whose general term is given. So the general term is given. So let's determine quickly the first 4 terms. Then, now this may be too easy and I don't want to waste our time. So you tell me if you want to work on 24 and 25. And the next one, it says the sequence is given using a recursion or recursive formula, right? Recursion formula or recursive. And write the first 4 terms of the sequence. So again, this is just a piece of cake, right? This one we will be able to simplify in a blink because now we understood how factorials work. This should only take a second to find the general term, the summation notation, and this one the same. So if you say, let's do this page, we will.
That's right.
Okay, very good. And that's fine. I'll let you choose. Perfect. So an equals -1 raised to n plus 1 divided by 3 to the n minus 1. So they're asking us to find a1, then find a2, then find a3, and then find a4.
So A1 is -1 raised to 1 plus 1.
Which is 2, very
raised to
good, over 3 to the first minus 1, which is 2, so it is indeed 1/2.
Hold on, is that 3? I have 2.
It may be the other handout. Just look at the other handout.
Oh, okay.
So a2, the last page. Yeah,
All my pieces have the same thing.
impossible.
23, 23. Okay, 23.
Okay.
All my pieces have the same. I'm looking at this one, right?
Yeah.
Yeah,
3.
so you give me 2 last week, and I have different one. But all of them have the same. Oh, you?
Sorry about that. I don't know what happened. Forgive me. It was not intentional. Okay, so -1 to the, very good, divided by,
3 squared minus 4.
which is 8. So -1 over 8.
Shucks.
Next one. -1 to the,
3
over,
squared is
3 cubed is 27, minus 1 is 26. 3 to the third, 27, minus 1, 26. And the last one,
oh, this whole thing.
-1 to the 5th power divided by 81 minus 1. So -1 over 81. Of course, 81 minus 1. Thank you. Well done. Now, in 25, the sequence is given as a1, which is 4, and an equals 3 multiplied by an minus 1, or an plus minus first, for n greater than or equal to 2. Again, the same question, the first 4 terms. a1 equals 4. How do I get a2? 3 multiplied by, yes. When this is 2, this is 2 minus 1, which is a1, which is given here. So 3 times 4 plus 3, which is 15. a3. Very good. 45 plus 3 is 48. Remember the order of operations. We multiply first. And the last one, a4. 3 times 48 plus 3. Yes.
I lost how it was 8.
Any of the sequence, the term of a sequence is 3 multiplied by the previous one plus 3. That's what it means. If this is 10, this is 9. If this is 11, this is 10. So any term depends on the previous one. So if I am given a1, then I have to multiply 3 by the previous term plus 3.
Oh,
Then if I need to find a3, I have to multiply 3 by the previous term plus 3. And for the a4, 3 multiplied by the previous term plus 3. Is that better?
yes.
Perfect. Let's simplify the factorials now. N plus 1 factorial over n factorial. So which of these two is bigger?
N+1.
Good. So how will you write n plus 1 factorial then?
N plus
N
one,
plus 1,
factorial,
and then N factorial.
That's it.
N factorial.
So this is n plus 1. You realize that we cannot do this with the graphing calculator.
Or just give us an error if we try.
I'm sorry?
Or just give us an error if we try.
You can't plug in n.
Oh, sorry.
Yeah. Okay, last one. No, there is one more. So we have 1 plus 3 plus 5 plus dot 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 plus 2n minus 1. And they want us to use the sigma notation or the summation notation. Same thing. Let's use what index? I, j, or k? K it is. From k equals what till what?
K equals 1,
Yes?
and then the
Till what?
And
Good.
And then you're left with K over.
2k minus
2K
1.
minus one.
Of course. Let's check. We still have to check. We still have to check. When k is 1, 2 minus 1 is 1. When k is 2, 2 times 2 is 4, 4 minus 1 is 3. When k is 3, 2 times 3 is 6, 6 minus 1 is 5. When k is n, 2n minus 1, 2n minus 1. Better? Very good. Last one. So 40 factorial divided by 450. We can't do this by hand. Impossible.
Oh,
So let's put it in. 40 factorial, go to math, go to probability, and choose item number 4. And now divide everything by 450. And look at this. This is humongous. I cannot even pronounce this. It's 1.813 times 10 to the 45th power. 45 zeros. So luckily the calculator did not run out of space.
you can't see.
Now, what do we do if it doesn't have space? What do we put?
Say it again.
If it doesn't have space,
Simplify it.
what would
It will give an error, so you have to go back and simplify like we did. Because the number will be too big. Very good. This is it about section 8.1.
Wait, hold on. 1.81.
It was 1.813, so it's 1.81. And then it said, had the E at the end, 45. It's like scientific notation.
I see, okay, thanks.
Good. So now let's go back and please choose from here. Oh, you want to go back to the first page? Okay. Would you like to do another Gauss-Jordan?
Yeah. No?
Yeah.
Is that hard?
It's kind of easy.
Oh, then no, do something else then.
I don't know the rest of it. I don't know anybody else. So I'm still.
Is it a yes on the Gauss-Jordan?
Oh, gee.
Let's skip over it.
Okay.
Yeah, let's not kill the rest of our study time.
Okay, so please choose. Pick and choose.
The first one, first one.
Number 1?
Yeah.
Very good. So in number 1 we have f of x equals 7 raised to the x. We are told to use this, but actually they want us to look at this function. So they want us to graph this function and also find the x and y intercepts algebraically. Okay, so where is the starting point here? Just 1 second, let me see. Oh, I have 39 minutes, it's fine. Okay, ready? So what are the transformations here? So the base function. Very good. Step number 1. The first transformation on 7 raised to the x power. Yes, indeed. What does this do when I change x into x plus 1? What does this do to this function? Awesome. Thank you. Left one. Step number 2. What do I need to do now? Not there yet.
-1.
Yes, multiply by -1. Negative this. What does this do to this? And it does not touch x, so it cannot be a change in x. It cannot be a change in x. We're not adding to y. Exactly, exactly. With respect to the x-axis. And number 3,
Add 49.
very good. -7 raised to x plus 1 plus 49. What does this do to this? Indeed. That's it. And then we will determine the x and y intercepts algebraically. You want to do the x and y intercepts first, and then we graph using transformation. Very good. Good pick. So I want to find the x-intercept. How do I find the x-intercept for any function, including this one? Perfect. I copy y. -7 raised to x plus 1 plus 49 equals 0. What type of equation is it, and what will be my next step? Sorry, Stephen, I didn't hear. It is an exponential equation or function. That's correct. It happens to be an equation, but it is an exponential function. True. Now what?
Add 49.
Not add.
Subtract.
Very good. Good. Now what? Yes. By?
-7.
Careful.
-1.
Correct. So I divide or multiply by -1. What now?
Well,
Yes, replace 49 by 7 squared. Why? Because both sides can be presented with the same base, and that's the easiest thing to do. So now here's how we think. Two numbers are equal, and they have the same base. What must happen to their exponents? We're not simplifying. We're not canceling the 7. We're just thinking. So what do I have to write?
X plus 1 equals 2.
Very good. So then x equals 1. Awesome. So the x-intercept is 1, 0. How do I find the y-intercept now?
X is 0.
Very good. So I have to find f of 0. So let's do this together. 0 plus 1.
1.
7 to the first power.
7.
Multiplied by -1.
-7.
-7 plus 49. 42.
Oh.
0, 42.
Oh, we're not gonna write it down.
So when I'm done with the final form, I better show that the y-intercept is 0, 42, and the x-intercept is 1, 0. Ready? Now I have to graph 7 to the x power. I have two possibilities for the exponential function. Either increasing on all its domain or decreasing on all its domain. Which one is it? It can only be one. Only if the base is less than 1. So the function will always be decreasing on all its domain if the base is between 0 and 1. Is it?
No.
No. So then it must be increasing on all its domain because the base is bigger than 1. 7. Very good. Where does it cross the y-axis? Always. A pure exponential function. 0, 1. So this is 7 raised to the x. Then you told me to shift this graph where?
Left one.
Very good. Where does my marker go? This is my marker.
Go to -1.
Very good. -1, 1. So this is the graph of 7 raised to x plus 1. Very good. Then you told me to do what with this? Good. Give me the marker again.
-1, -1.
Awesome. So this is indeed a -7 raised to x plus 1. Now remember, these three functions have a horizontal asymptote. Where? Perfect. When I shift the red graph up, how many? Where will y equals 0 shift? Exactly. So I'm going to say that this is y equals 49. And it should have been a dashed line, and I'm going to make it because that's not part of the graph. It's just a horizontal asymptote.
I'm writing a pen here.
Yeah. I faked it. Okay then, so please give me my marker again. Where is my marker going now?
With the 48.
Yes, to negative 1 comma 48. Now, since we determined these two already, and 1 comma 0, and I'm going to say that this is, so 42 should be lower. I'm going to say it's 42 here. 0 comma 42 and 1 comma 0. So here's the graph. So this point moves here. Yes, you do. So this is y, or our function, negative 7 raised to x plus 1 plus 49. And I think it was denoted by g. Bless you.
Thank you.
Okay, moving on.
So our job.
Okay, I'd like to look at problem 5. We'll come back. If we have time, we're going to finish it next Monday if we don't whatever we don't finish today. But I would like to give you the spectrum, not just one type of problem. Okay, so let's look at problem 5. We're given the function f of x equals 542, 1.026, everything raised to x. Models the population of a country in millions x years after 1970. What does 1970 represent? Which is x equals? Very good. So the country's population in 1970 was the country's population in 1997, and then 2024, and then 2051, and then it asks us to come up with a model or some conclusion that we see from the data. So 1970 means, you already told me x equals 0. 1997 means x equals
27.
2024 means x equals
54.
and then 2051 means x equals
80.
good. I'm not going to do this by hand. I'm going to put the function in the graphing calculator under y equals. Clear if you have anything in there. And you copy 542 in parentheses, 1.026, close the parenthesis, caret, in parentheses, x. And now you tell me, let me check because the calculator here always goes back to default. I'm sorry. So I go back to second and table. Again, what do I plug in? So in 1970, it was 542. In 27 years later, 1083. 27 more years later, 2167. 27 more, 4334. I'm going to copy all these numbers. And the question is asking us to, what appears to be happening to the country's population every 27 years? It doubles. 500 times 2 is 10, roughly 1083. 1083 times 2 is roughly 2167. 2167 times 2 is roughly 4334. So which of these four options will you fill in? D, it appears that the population is growing by a factor of 2 every 27 years. Are you looking at the problem? Item D, as in dog. So please copy these numbers on the paper so you have it. So 542 1084, 2168, and 4335. Pretty straightforward, correct? We've done this before. Agreed? Okay. Let's take a look at problem 8. I'm sorry? Yes, let's do 6. Oh, there is no 6. Oh, 6? Yeah, yeah. Sorry. Yes. So let's do 6. Yes. D as in dog. D. Yeah. It doubles. The population doubles. Yes. Is that okay? Any questions, please? Okay. So we are given f of x, which is 6.19, 1.029 raised to power x. We are given g of x, which is a logistic growth model, 37.3 divided by 1 plus 6.1 e to negative 0.052x. Which function is a better model for the percentage who were college graduates in 1980? And we are told that X years after 1950. So what does this represent? Yes, so we are looking at X equals 30. We have to plug them in and plug in 30. That's all. So in Y equals, clear, and just put in two functions. The first one is 6.19. And in parentheses, a 1.029 caret x. And the second one is 37.3. Please make sure you put parentheses around the denominator. 1 plus 6.1 times e raised to, in parentheses please, negative 0.052x, close the parenthesis, come down and close the parenthesis for the denominator. And then we go to second in table, and we want to plug in 30. So the first answer is 14.6, and the second answer, second function, g, is 16. Choose the correct answer below. Which function is the better model for the percentage who were college graduates in 1980? So I look at the page, at the graph, and I see 17. Which of these two is closer to 17? That's the better model. G. That's it. Very good. Okay. Yes?
Can I see your input before that?
The functions?
Yes, please.
Sure. Okay, I would like to refresh our memory on exponential, like 11, exponential equations, and logarithmic equations like 13, and then we come back for more. Any questions? Any questions on this?